So section 7.1 is a big section that we were already introduced to the general solution in the first example that we did. And this type of question, I give it a special name. I call this a multi-revolution question. And a multi-revolution question is what happens when you have a horizontal stretch or compression while you're trying to solve. So in this question, it's solve sine 3x equals 0. And we're trying to solve between 0 and 2 pi. So what I'm going to do is off to the side here, I'm going to write out the steps, and we're going to try to solve it as we're writing out the steps to see what the steps mean. So first, when you have a multi-revolution question, you recognize that because we have a number in front of x, sine 3x equals 0. We're going to start by stating the domain and I'm going to put 3x in quotation marks because it could change. We're going to state the domain for 3x. If it was sine 4x equals 0, you'd state the domain for 4x. Now, what is the domain right now? X is between 0 and 2 pi. So what would 3x's be between? Okay. Now, if I got you to pick a number between 1 and 10, okay, you got a number in your head? Now I told you to multiply it by 3. Everybody would have a number between 3 and 30. So if x is between 0 and 2 pi, does it make sense that 3x's would be between 0 and 6 pi? And if we think about our unit circle, if you went from 0 to 6 pi, that would be once around to 2 pi, 2 times around to 4 pi, 3 times around to 6 pi. And so we would have to go around our circle more than once. That's where I came up with the name multi-revolution, because you're going around more than once. Okay? So step 1, you state the domain for 3x. Step 2, solve for 3x. In other words, if this was sine theta equals 0, you would next write theta equals and write all the answers. So our angle is 3x, so we're going to write 3x equals and write down all of the answers. Now, when is sine equal to 0? So on your pi plate, it's the y coordinate. When is it equal to 0? It's equal to 0 and pi and 2 pi. That's one time around, right? Second time around, you would get, well, before 4 pi, 3 pi, and then 4 pi. Third time around, you would get 5 pi and 6 pi. Now, I just realized I made an E8 error. An E8 error is an error with domain and range. Read the question carefully.
Oh, less than.
It just has a less than, and I included the equal sign there. Can you see yourself making that mistake?
How would you do that in the other type of notation?
How would you do this in the other type of notation? This is from 0 to 2 pi round bracket. Okay? And because 6 pi is not included, I'm just going to put an X through that one because that one's not supposed to be included anymore. That's really not nice of the textbook to do that to me. So we have done step 2. We solved for 3x. And then step 3, put x, because it could be a theta. But now we need to get x, because the whole question was solve, the variable is x. We've solved for 3x. How would you get x by itself? divide by 3. So if 3x equals 0, then x is equal to 0. If 3x equals pi, then dividing by 3, you would get pi over 3. Divide by 3, 2 pi over 3. Divide by 3, 3 pi over 3, which is just pi. 4 pi over 3. And 5 pi over 3.
How many steps in total are there?
3. We're done. We have now solved the multi-revolution question from 0 to 2 pi. Because x is equal to these 6 answers, and all of those answers are between 0 and 2 pi. The reason is because what does the 3 do? It does a horizontal compression of a third. So does it make sense that everything that was originally between 0 and 6 pi now would get squished between 0 and 2 pi? We do the reciprocal, we just do it later, yes. So some people wonder, why don't I multiply everything by third at the beginning? Well, we're originally getting all the answers from 0 to 6 pi, and then when we do that 1/3 and squish it, we'll have all of the answers that would be there in the end. Yes?
Just notice, so like pi would be like infinity bracket instead of square.
This round bracket means that you don't include 2 pi. Okay, so these are our steps. Now, part B says state the general solution. If we look at our notes from yesterday, it says you can find the general solution by A, first solving between 0 and 2 pi. We've done that already. And then adding 2k pi to all of your answers. So since we've solved between 0 and 2 pi already,
Are we ever going to be given like sine 1/3 of x?
yep, it's possible. And so our general solution then is take all of your answers that you have from 0 to 2 pi, which is 0, pi over 3, 2 pi over 3, pi, 4 pi over 3, and 5 pi over 3, and add 2k pi to each of them. Where k is an integer. And then we've written the general solution. If you want to be creative, there's probably a way that you could write all of those much shorter. Okay, but this is perfectly fine. So I'm going to give you a couple more examples. I will actually show you some of the shorter ways to do a general solution for multi-revolution. But for now, this is fine. Okay, so here's our first example. We're going to do 2 more examples. So if you run out of space, there is at the end of 7.1 on page 583, there's a whole extra space. So if you want to go to 583 and write more multi-revolution questions, then you have lots of space to do them. So we're going to solve for theta, where 0 is less than or equal to theta is less than or equal to 2 pi, for cos 2 theta equals negative root 3 over 2. So step 1, if theta is between 0 and 2 pi, then 2 thetas would be between 0 and 4 pi. So we're going to have to go twice around our circle this time. Then we solve for the angle. What angle gives us negative root 3 over 2? So 2 theta equals. What family is that for cos? Close? Pi over 6. Pi over 6 family. And then you're going to look in quadrants because cos is negative. Quadrants 2 and 3. So what's my pi over 6 in quadrant 2? 5 pi over 6. What's my pi over 6 in quadrant 3? 7 pi over 6. But this is only my first time around. 2 thetas are between 0 and 4 pi, so we need to go a second time around. If I went all the way around once and then got to 5 pi over 6 again, what number would that be? Well, I'd have to add 2 pi, correct? That would take, if I'm at 5 pi over 6 right here and add 2 pi, I'm going to be coterminal with it again. And 2 pi over 6, 2 pi is the same as 12 pi over 6. If I'm going to add, I'm going to need a common denominator. So then 5 pi over 6 plus 12 pi over 6 is going to give me 17 pi over 6. And 7 pi over 6 plus 12 pi over 6 is going to give me the limit for 2 theta is 4 pi. The limit for theta is 2 pi. Now I've got my 4 answers. And does it make sense for most things? There's always 2 quadrants where it's positive and 2 quadrants where it's negative. So on the first time around the circle, for most angles, the only one that doesn't work is the axes family if you have like 0 pi and 2 pi. But for the most part, when you go around once, you'll always get 2 answers. This one, we go around twice. We should get 4 answers. So now, if I want to solve for theta, I'm going to have to take all of those answers and divide by 2. Do you know that dividing by 2 is the same as multiplying by a half? And if I multiply by a half, math is going to be easier than dividing, because then I just have to multiply 5 pi times 1 and 6 times 2. In fact, I'm just multiplying my denominator by 2. Quick mental math. Can you see that all of those answers are between 0 and 2 pi? So what's the highest you could go if it was up to 2 pi over 12? 24. 24 pi over 12 would be the highest you could go. And the highest we're at is 19 pi over 12. So all of those answers are between 0 and 2 pi. Now, if the question said, what's the general solution? You could take those 4 answers and add 2k pi to each of them. And now I'm going to show you a second method for solving the general solution for a multi-revolution question. So far, the first method we've always had to solve between 0 and 2 pi first, and then we were asked the general solution after. So it made sense just to add 2k pi to each of our answers. But sometimes you're going to just get a question that just says, find the general solution of, and you don't have to solve between 0 and 2 pi first. Okay? So here's the question. It's exactly the same, but it starts off by just saying, find the general solution of cos 2 theta equals negative root 3 over 2. Exact same question as we just did. If you wanted to use the method we just did, it would work perfectly fine. But this is a second method. In this method, what you do first is you write the general solution for 2 theta, or whatever the multi-revolution is. And then you can write the general solution for theta. So what does this mean? Well, if I wanted to do my general solution normally, okay, if I wanted to do it for 2 theta, I would write 2 theta equals, solve for 2 theta between 0 and 2 pi, just once around. When do we have negative root 3 over 2? We figured that out to be at 5 pi over 6 and 7 pi over 6 plus 2k pi plus 2k pi, where k is an integer. That's how you would do a general solution if it was just an x inside, or just a theta. You'd Yes. So you would still have to think about when is cos negative root 3 over 2, pi over 6 family, quadrant 2 and quadrant 3, 5 pi over 6 and 7 pi over 6. Okay? In the difference, in the last time we had to go twice around the circle, right? You went once around, twice around to get the 17 and the 19. This time we don't have to get the 17 and the 19. Because after we found the general solution for 2 theta, we can write the general solution for theta, which is multiplying by a half, 5 pi over 12 plus, and it's no longer 2k pi, it's now plus k pi, because you have to multiply that by a half as well. And 7 pi over 12 So this answer is identical to the last answer, just written differently. The last answer had 4 of them plus 2k pi. This one only has 2, but now you're only having to go halfway around. This would be a nicer, well, for one, can you see your answer is a little bit smaller? So it's nicer that way. And it is nicer if you had, say, we'll do one where I have 9 revolutions around the circle. You would normally have to write out 18 answers and then have to go plus 2k pi for all 18 of them. So this method is sometimes nicer for that, yes. With the 2 lines? Yeah. You do, for sure. Oh, just makes you happy. Doesn't it make, like when you make the R, doesn't that make you happy, that extra line? No? Oh, you're missing out on a lot of happiness.
Like, do you actually have to?
Yeah, I want you to be happy. So one more example. Find the general solution for tan of 9 theta equals negative root 3. Using the second method. 9 of theta would equal, when is tan? Negative root 3. What family? 60 degrees or pi over 3. Okay? It's going to be negative, so quadrants 2 and quadrant 4. So you would have in quadrant 2, 2 pi over 3. In quadrant 4, 5 pi over 3. Plus 2k pi So this is our technique of finding the answers from 0 to 2 pi and adding 2k pi. That solves for the general solution for 9 theta. The general solution for theta then, divide by 9, 2 pi over 27, plus 2k pi over 9, and 5 pi over 27, plus 2k pi over 9, where k is an integer. So if you just had to do the general solution, this way is more elegant. However, you will find often that your textbook asks you to first solve between 0 and 2 pi, and then write your general solution. Then this is more work. Then just take your answers that you got from 0 to 2 pi, add 2k pi to all of them. It's just as fast. So, our question for practice, number 10.